All right, we're still working on properties of exponents. We're on example 5. So we will need to simplify a real-life expression. Which of the expressions shown represent the volume of a cylindrical can where R is the radius and H is the height? So it shows a can here, and it shows us that R, our radius, is H over 2, and it shows the height of the can is going to be H. So what is the volume? All right, so first we have to know what is the formula for volume of a cylinder. So volume equals your circle times your height. So volume or area of a circle is pi r squared. So the area of a circle times your height gives you the volume of anything that's like cylinder shaped. All right, so let's look at how to simplify this. So we're going to have volume equals pi r squared. We have h over 2 is our radius. We're going to square that times h. So our volume equals pi. We're going to have h squared over 2 squared. 2 squared is 4 times h. So our volume equals pi h cubed over 4. All right, so pi h cubed over 4. So we can immediately see that this is a solution. All right, but it says which of the expressions shown represent the volume, which means it can be more than one. So we need to check all of these to see if any others can represent the volume of this cylinder. So we know this is how we simplified it, but it may be written in a different format. So let's check 2 pi r cubed. Let's see, 2 pi, our radius is h over 2. And it says 2 pi r cubed. So our radius cubed. So we're going to have 2 pi h to the third power. 2 cubed is 8. This is the same as 2 over 1, so we can reduce this. So that becomes pi h cubed over 2 goes into 8 4 times. So pi h cubed over 4. So we can see that this one is also equivalent to that. It was just written in a different format. This one was written in terms of your radius instead of your height. All right, so let's check the one beside of it. All right, pi h cubed and then 2 to the negative 2. 2 to the negative 2 is 2 squared moved to the denominator. So pi h cubed over 4, again, that is a solution because it's equivalent when you rewrite it. All right, here we've got pi h to the 4 raised to the negative 1. So let's look at this one. So you've got pi h 4 to the negative 1. So the 4 to the negative 1, it will become pi h over 4. We're missing the cube power, so that one is not equivalent. All right, pi h squared over 4. That one also is not cubed, so that one is not a solution. Pi h cubed over 2. That one needs a 4 in the denominator, so that one is not a solution either. So if you look at these and rewrite each one of these, you can see that there are 3 correct solutions that represent the volume of this cylinder can. Last example, example 6, modeling real life. A jellyfish emits about 1.25 times 10 to the 8th power particles of light or photons in 6.25 times 10 to the negative 4 seconds. How many photons does the jellyfish emit each second? Write your answer in scientific notation and in standard form. All right, so what do we need to do? First, we need to decide what to do. So we need photons per second. So we're going to have to to find the unit rate of photons per second. So we're going to have 1.25 times 10 to the 8th divided by 6.25 times 10 to the negative 4. All right, so what we can do, we see that we are multiplying. These have the same base, these do not. So what we can do is kind of separate this. So we can write this as 1.25 divided by 6.25 times 10 to the 8th over 10 to the negative 4th. Then we can simplify this. So let's look at 1.25. So we've got 1.25 divided by 6.25, and that's going to be 0.2. So we can put 0.2, we can put 0.2, same thing. All right, times 10 to the 8th divided by 10 to the negative 4th. So we can use properties of exponents here, same base. We subtract from top to bottom. So 8 minus negative 4. 8 minus negative 4 is 8 plus 4. 8 plus 4 is 12. All right, having trouble with my pen, sorry. All right, so the only thing we need to do is remember that scientific notation, your number is between 1 and 10. 0.2 is not between 1 and 10. So if this number, if the decimal moves over, if this number gets bigger, the exponents get smaller by 1. So I'm going to move this over and make this 2 times 10 to the 11th power. So these two expressions are equivalent, but this bottom one is in scientific notation because we have A is between 1 and 10, and then times 10 to some power. All right, so again, scientific notation should be review, but just so you know. All right, so let's look and see. It says, write your answer in scientific notation and in standard form. All right, so this is in scientific notation. Standard form means we have to write it out with all the zeros. So if we write it out with all the zeros, we're going to have 11 zeros after that. So there's 2, 5, 8, 11. So the jellyfish emits 2 times 10 to the 11th power, or 200 billion photons per second. That's a lot of photons per second. All right, so what is 200 billion photons per second? Well, remember it said that it is particles of light. So a jellyfish is emitting that many particles of light in a second. So that's pretty incredible. All right, if you have any questions, please let me know.